Limits of a function.
Okay, so lovely people, we are once again on the WASI concept, WASI electric math concept. Today we're looking at calculus, which is differentiation. But we're looking at the introduction of differentiation, which I'm doing limits of a function. Limits of a function. Now, for every given function, anytime you have a function, let's say f of x, and we say that the limit of the function, if you find the limit of the function, which is f of x, as x approaches a constant, let's say a, for every given function f of x, and you have to find the limit of that function as x approaches a. What it means is that you have to find the behavior of the function. You are finding the behavior of the function. The behavior of the function for values of x around a. So now if you are given a function and you have to find the limit of that particular function of x as the x is approaching the constant a, then we are looking at the behavior of that particular function of the values of x around a. So for instance, if we have limit of x plus 2 as x is approaching 3. So now I have to find, this is the function, and I have to find the limit of this function, f of x, as x is approaching 3. Then what it simply means is that the limit of the function becomes the value of x around 3. So the behavior of this function for value of x around 3, that will be 3 plus 2, and that will give us 5. So now anytime you have a limit of a function f of x, where x is approaching the constantly, becomes the function itself of a. The function itself of a. That is the value of the x around a. You find the limit of that. Another example, if you have the limit of, let's say, x squared minus 4x plus 2. And I'm going to find the limit as x approaches 2. As x approaches 2. It is the value of x around the constant, the value of x around a, which simply becomes 2 squared minus 4 times 2 plus 2. Now when you do this, you get minus 2. You get minus 2. Okay, so with this said, let's look at finding the limit of rational functions. Finding the limits of rational functions. Finding the limit of rational functions. Now, if we say we have a rational function, say limit of f of x as x approaches a, where f of x, so where f of x is a rational function, where f of x is a rational function, what happens is that you can always substitute a rational function to its simplest form. You can always simplify a rational function to its simplest form before you find its limits. So now, if you want to find this to its simplest form, you can maybe perhaps get limit of h of x divided by g of x as x approaches, let's say, a, which will give us the h of x all over the g of x. So now, if the limit of function of f of x can be simplified to h of x given g of x, then we want to find the limit of this and to be the same as the limit of that as x is approaching the a. So you can simplify a rational function to its simplest form before you make your substitutions of the a. So now this now becomes the h of x we are getting here. If you want to make the substitution of the a as x approaching a, then it becomes h of a divided by what? Our j of a. So now what it means is that I have my limit of a rational function f of x as x approaches a. The f of x function can be simplified to, let's say, h of x divided by j of x. Then my limit now becomes limit of x approaching a, h of x divided by j of x. So if that is the case, then my limit can now be what? H of a divided by j of a. And this is the limit of a rational function. The limit of a rational function. Let's take two examples. Let's take two examples here and look at how we can deal with it. So, example 1. You have to find the limit of x squared minus 1 divided by x plus 1 as x approaches negative 1. So the limit of x squared minus 1 divided by x plus 1 as x approaches negative 1. So now if we have a question like this is a rational function. We can simplify it further down. So if you want to do it, the x squared minus 1 divided by x squared plus 1 can be simplified to x minus 1 into bracket x plus 1 or divided by x plus 1. So now when you do this, what you get is that the x plus 1 can take this x plus 1 away. So finally we get what? X minus 1. So therefore the limit here can now be limit of x minus 1 as x approaches minus 1. And when you do this, the behavior or the values of x around the limit a becomes negative 1 minus 1, which is equal to what? Negative 2. So anytime you have a rational function, you have to simplify the rational function first. Okay, let's take another example. Let's take another example. We are asked to find the limit of x cubed plus 3x squared minus 9x minus 2 all divided by x cubed minus x minus 6 as x is approaching 2. As x is approaching 2. Okay, now with this, you realize that it's a polynomial function of the degree, the highest degree 3. So now we can simplify this down. Now when you check these two polynomial equations, there is a factor over there which is 2. So these two polynomial equations have a factor of 2. That is to say they have a function which is become x minus 2. So we can divide each of the equation by x minus 2 to get the other cell. So when you do that, when you take the numerator, x cubed plus 3x squared minus 9x minus 2 divided by x minus 2. Okay, so when you do this way you can get, so x goes here, which is x squared times this, which becomes x cubed, x times this becomes 2x squared. So now we subtract from this, and when you subtract, what you get here 0, you get here plus 5x squared minus 9x minus 2. So this is the long division for a polynomial function. Now x goes here how many times? That is plus what? 5x. So this one gives 5x squared. 5x minus this should give what? Minus 10x. So to subtract it, this goes to 0. This minus here. So when you do this, you are getting plus x minus 2. Okay, so now x goes here how many times? Which is plus 1. So when you do this minus this, that gives you plus x minus 2. So when you subtract this, you are getting what? 0. So when you get 0, that means the factor now becomes x minus 2 multiplying x squared plus 5x plus 1. And when you do this multiplication, you get the numerator back. You can work the same way for the x minus 2 for the denominator because they are all factors of 2. So x cubed minus x minus 6 Now, when you do this systematically, I'm giving you the answer straightforward. This is not part of limit of function you are doing. So I'm giving you the answer straightforward, but you can look at your polynomial, that's other videos, and know how you can do the division. And when you do that, this is what you are getting x squared plus 2x plus 3. So now you're getting x squared plus 2x plus 3. And that will give you x minus 2 multiplying x squared plus 2x plus 3. Okay. So when you get this, what happens is that from here, you can simply find that now the limit as s is approaching 2 of the function becomes x minus 2 multiplying x squared plus 5x plus 1 all divided by x minus 2 multiplying x squared plus 2x plus 3. So the x minus 2 can take x minus 2 out here. And when you put the limit inside, as s approaches 2, then it becomes 2 squared plus 5x, 5 times 2 plus 1, all divided by 2 squared plus 2 times 2 plus 3. And when you do this calculation, you'll be getting 15 on 11. You'll be getting 15 on 11. Okay. Now let's move on to the other one. Let's move to the other one, which is finding limits involving infinity. That is this symbol. We want to find the limit of functions that involve infinity. The limit of functions that involve infinity. Now, the limit of a function as s approaches infinity becomes, or as s becomes very large, is noted by this. So the limit of a function f of x as s approaches infinity. Now, if the f of x is equal to g of x on h of x, then we can say the limit of f of x as x approaches infinity can be found by first dividing the numerator by the denominator, that is the variable with the highest degree, and also or the variable with the highest degree, or the variable with the what? The highest power of x. So that is to say, if you find the f of x that is equal to g of x, h of x, that is the function g of x, h of x. So let's say the function g of x has its highest degree by x cubed. Then you'll be dividing the whole, or the whole function has highest degree of x cubed, then divide the whole function by what? S cubed. I getting it? Because of the limit is approaching what? Infinity. Now this one, let's take this example. But before the example, you have to note that one. Anytime you have the limit of 1 over x exponent n as x approaches infinity, it is equal to 0 if n is positive. If n is positive, or if n is greater than 0. Now, if you have also a limit of x exponent n as x approaches infinity, this limit does not exist. So the limit of x of n as x approaches infinity does not exist. Now let's take some examples here under the limit involving infinity, and let's look at them. Okay, so example 1, it says we should find the limit of 5x squared minus 1 all divided by 2x squared plus 5 as x approaches infinity. We are asked to find this limit. 5x squared minus 1 all divided by 2x squared plus 5 as x approaches infinity. How do you go about it? First of all, the highest degree here is what? Is x squared. So you have to divide each of the term of the function by x squared. So now you start this way. The limit as s approaches infinity. 5x squared divided by x squared minus 1 divided by x squared, all divided by, you come to the denominator term, 2x squared divided by x squared plus 5 divided by what? X squared. Now what happens is that when you do this, you now can come to limit as s approaches infinity. This s squared will take this away, so we get 5 minus 1 on 1. X squared. All divided by, this also takes this away, so you get 2 plus 5 on x squared. And now when you do this, what do we get? You realize that anytime you say we have a limit of s approaching infinity, 1 over xn is equal to 1. When the n value is what? Is positive. Then if that is the case, then we can say this one will give us 1. So we have 5 minus what? Minus 1. And, sorry, this limit, when n is this, it will give us 0. Sorry for that. That is the equation here. It's not 1. So therefore, we have 1 minus 5 minus 0, all divided by 2 plus 0, which will give us what? 5 on 2. Which will give us 5 on 2. Let's take one last example of the limits involving infinity. One last example of the limits involving infinity. So let's do second example. Find the limit of 2x cubed minus 7x plus 3 all divided by x cubed plus 2 as x approaches infinity. So we have to find this limit. How do you go about it? So 2x cubed divided by x cubed. So the limit as x approaches infinity minus 7x divided by x cubed plus 3 divided by x cubed all divided by x cubed divided by x cubed plus 2 divided by x cubed. So this one will take this away. This will take one of this away. Okay. So now we get 2 minus 7 divided by x squared plus 3 on x cubed all divided by 1. So this one will give you 1 plus 2 on x cubed. So you are finding the limit as x approaches infinity. So what we get here is that we get 2 minus 7 on x cubed, the limit of that will give you 0. 3 plus on x cubed, the limit of that will also give you 0. Divided by 1 plus 2 on x cubed, the limit of that will give you 0. So we realize that finally we get to what? The limit of 2. Okay. So this is the limit of function. Let's meet on the other videos and talk about the limit of a simple trigonometric function.